Hi everyone, welcome back to the AI language. So today we are building something absolutely magical, a vision agent using Google's Agent Development Kit or ADK and the agent to agent protocol. And here's the twist. This agent can see and analyze images based on any query you give it. So whether your image is a public URL or a local file like so, this vision agent can understand what's in it just like a human would, thanks to Gemini's vision capabilities. So this is an image of a early 1990s or late 1980s computer that I've chosen as a desktop computer to analyze, and just chose this because it's pretty amazing how we have reached from such computers, early stage computers, which were actually very complicated for their own time and advanced technology for their own time, to talking about things like artificial general intelligence and the Gemini and OpenAI and so many other models which are now beginning to describe these images as a human would. So let's continue with that thought that we are working on amazing technology and then building even better applications to help other people out. So let's see it in action first, and then we'll dive into how you can build it from scratch. On the left, you can see that I've got multiple images open. So I have the image of an old desktop computer. I have the image of a bus standing in rain and people getting onto it on the bus stop. There's also an image of a beautiful butterfly on a flower, and there's the image of a rainbow over a garden. On the right, you can see that I'm going to launch my vision agent over here, and I'm going to press enter, and this will basically start my vision agent on the port 10003 on localhost. I also have my host agent, which I'm going to start over here. This host agent is what we've already built. It's like a universal orchestrator agent, which we built earlier using the A2A and MCP protocols. And it's like a router that basically connects to other specialized agents via A2A and MCP servers via MCP. So it's able to use the other agents and all the MCP tools on those MCP servers. And that's why we call it a universal orchestrator agent. So let's run this now. So now we can look at this and we get this log which says that registered A2A connector for Gemini Vision Agent, and so we know that this is connected. There are also a couple of other agents running on port 10002 and 10001 which we have used in the earlier lectures, and this is the greeting agent and tell time agent which are also connected. So we have made sure that everything is up and running. Our host agent is active on port 10,000 on this particular terminal window on localhost, and our vision agent is basically active on 10003 on localhost on this particular window. Now we just need to start our command line interface client app. For that, we can actually run this command and press enter, and now we get the query, what do you want to send to the agent? So this is basically connected to the host agent which is on port 10,000. Let's first ask the host agent what all tools does it have access to. Alright, so I'll say, can you tell me what all tools and agents you have access to? Something like that. Let's press enter, and we see that it's sending a JSON RPC request to the host agent, which is open over here. And the host agent processes this request. It will try to list all the tools. We can see that it's trying to list the MCP server tools over here. And let's see what response we get. So it says, I have access to the following agents and tools. The greeting agent that greets you based on the current time, and then it has this greeting tool which returns a greeting based on the current time of the day. So this is basically the skill of the agent. And then we have the tell time agent. This agent replies with the current system time. Gemini Vision Agent is the third one, and this agent answers questions about images using Gemini Vision. And the skills is basically one of the skills which we have given this agent is the image query tool, and this can answer questions about the content of an image. There are some inputs about how the string format must be. So there must be a question followed by a double pipe and the image path or URL. So this basically goes in like this. And then there are other tools. So basically there's a run command tool which it can use to run or execute commands on the terminal. And this is one of the tools that we expose using the MCP server. So please do look at the previous lecture and you'll understand the context for the other agents and tools that are there over here. What we're going to focus on right now is the Gemini Vision Agent. So let's ask our host agent to tell us what's there in this particular image. So I'm going to say, can you describe the image at, and then I need to give the path. So what I'll do is I'll go over here, I'll right click on this and I'll copy the path. Let me paste this path over here and let's press enter. Okay, so it's now sending this request to the host agent. The host agent will decide which agent to then forward it to. Based on the skills available, it should forward it to the vision agent. So let's see if the vision agent has something. So yeah, it has gotten a request over here and it started to produce the output, shows an old computer system. So now let's see what we get over here. All right, so we got the response over here and we have, here's a description of the image. The image shows an old computer system with a beige color scheme. It includes a CRT monitor sitting atop a computer tower, a keyboard and a mouse. The screen of the monitor is black. Over here, the computer tower features a CD-ROM drive, this one, and the overall style suggests a vintage or retro aesthetic. And this is probably something like a 1990, early 1990s computer or late 1980s. So guys, isn't that mind-blowing that we have a host agent now, which is connected using the A2A protocol to several other agents. We saw that in the beginning. And it is intelligent enough to decide which agent should it send the request to. So when I sent the request using this command line client, it went to the host agent over here. The host agent then took that request and sent it to the vision agent over here. The vision agent sent a reply. You can actually see the host agent screen has this reply over here. And then it sends back to the command line client app, which says that, this image shows this old computer. So this is pretty amazing. Let me try actually another image. Let's try the bus stop one. So again, I'll say, can you describe the image at, and then let's copy the path from here. So I'm going to take the bus stop path from here now, and let's paste it over here. And let's press enter. So you see that the host agent now has a request over here, describe the image with the bus stop one, and then it should decide to send the request to this particular model. And this model has now got this request and it's producing this output over here. And now if we go back over here to our client app, we see that we have the response that the image captures a rainy scene with people boarding a bright yellow bus. The rain is visible as it streaks down across the windows and umbrellas held by some of the individuals. The people are dressed in coats and hooded jackets, carrying bags or backpacks, suggesting they are commuting or traveling. The overall mood is a bit gloomy due to the weather, but the yellow bus adds a pop of color to the scene. So this is pretty amazing that the AI over here is able to describe this image using the host orchestrator agent. So you can actually try out the other images yourself. For example, we have the butterfly image over here and the rainbow image over here. And since we have tested it for these two, this should work pretty well. I'll just tell you how to set this code up. There's a link in the description. Please use that to check out the code. Once you have checked out the code, you will see a folder structure like this with A2A samples. This covers all the previous samples that we have done. We had done a version 4 multi-agent MCP sample before, and version 4 P01 is basically 4.01, which extends version 4 by adding a vision agent. When you expand this folder, you'll see that we have these 4 agents over here. The host agent is the one that does all the magic of orchestration. Then you have the greeting tell time agent and the vision agent as well. There's a command line app over here, which we are using in this terminal over here, which is actually used to send the queries. You also have different models, server code, and different utilities for A2A and MCP. All right, so once you have checked out this code, you can shift to the directory that you have checked it out to. So I have checked it out in under A2A/A2A samples. Then you shift to the version that you like to see. So we want to work on version 4.1. So we'll shift to that particular directory. Then you can see that I already have a virtual environment folder over here set up. I have a Python version file and a PyProjects file. When you get the code, you're not going to have the env and the venv folders. So just to simulate this, I'm going to actually delete these two. Okay, so I have deleted the virtual environment directory and the env file over here just to show you how to set this up. Now you can actually do uv-venv. This is going to set up your virtual environment folder again. So we can see that this should have come up again over here. Now what we do is we do source.venv/bin/activate. And this is going to activate our virtual environment. Now, since we already have the pyproject.toml file, you can actually click on this and see that all the dependencies are defined over here. To install these dependencies very quickly, you can just type uv sync -- all -groups, and this is going to install all these dependencies in the virtual environment over here. So now we have all these installed. You can see that you have Google ADK as well, which we are using. Now we need the environment variable file. So we're going to type touch.env, and here's the file over here. And this file is currently empty. So what we need to do is we need to specify Google _API _key over here equal to, and we need to put the Google API key. I'm just going to tell you now how you can get the key. You can actually go to aistudio.google.com and log in through your Gmail account, and they're going to give you a Gemini API key for free. So there are some terms and conditions that you can check when you take this key, and essentially you can actually use it for free for testing purposes with certain lower limits, and by allowing them to use your data while training their model. And this then makes it an ideal choice for this tutorial and experimentation. So I'm on aistudio.google.com, and when I visit this site, it automatically gives me a prompt to get an API key over here. And otherwise, I think there's a button over here also to get the API key. So I'm just going to click on get API key over here. Okay, so there's a code to test the Gemini API, and there's a create API key button over here. So let me just use the API key from here. It's going to now generate the API key for me. And you should use your API keys securely and not share them or embed them in code that the public can view. I'm going to disable this after the tutorial. For now, I'm just going to copy it from here and let it be visible. Alright, so once you have the API key, we'll head back to our .env file over here and just paste the API key over here. I'm going to just leave it visible over here, but we'll disable this after I release this video. Just note that we need to keep this secure, as I mentioned earlier. Alright, so once you have this environment variable set up, you have your .venv folder and all the packages installed, you're good to go. I'll just also show you how to run the different agents. Let me close all the other agents and start them again. Alright, so I've closed all the pre-running agents just to show you how to start these agents. I'm on a blank terminal over here. Let's go to the folder where we have downloaded our code. Alright, so I've shifted to the version 4.01 folder with the VisionAgent. Now let's activate our virtual environment. Let's type source.venv. So we type source.venv/bin/activate, and this activates the virtual environment. And now we can run the agents. So to run the agents, we type uv run python 3-m agents dot and then the name of the agent that you can actually see from here. So these are the 4 agent names that we have. So I'm going to start the VisionAgent first. Let's press enter. And now the agent is running on this default host and port, which is localhost 10,003. To show you how to run the other agents, I'm going to press Ctrl+C to quit. And now I'm going to start the next agent. So this starts the tell time agent on port 10,002. Let's also see how to start the greeting agent. This starts the greeting agent on the default localhost port 10,001. Let's also see how to start the host agent. Just the way it's set up, you also need to specify the entry.py file over here after host agent with just the .entry word over here. Let's press enter. So this starts the host agent, which runs on the default localhost 10,000. In a typical situation, you'll have multiple terminal windows, each running one agent, and then you'll see that all these connections will succeed to the different agents. Let's close this for now. Now let's try to start our client, which is the app, command line based app, where we actually send the queries to the host agent. To start that, we type uv run python 3-m and app.cmd.cmd. And this basically starts our client where we can actually write a query, and this is then going to send it to the host agent. The default agent that this client connects to is localhost 10,000, so it will connect to this. You can actually specify the agent URL while starting this app, and then it will connect to a different agent if that is what you want. Let's type :q to exit. And now you know how to start the app and the different agents, and you can check out this code and test it out yourself. And it is pretty amazing to see how one host agent can actually work with so many different agents over A2A, and also one of the MCP servers with the run command tool over MCP. Alright, so now let's take a quick walkthrough of the code that we have. Please see the previous lecture, which has the details about the host agent, the tell time agent, and the greeting agent, and how it all works with the orchestration logic and the client and the command line app that we have over here. This is all covered in version 4. What we have new is version 4.01, which has a new VisionAgent. So I'm going to cover the changes that I have made in this particular code. So let me go through the VisionAgent first. Alright, so let's maximize this and let's go to the VisionAgent. So we have the first file, which is the main.py file. And this is the entry point for this particular agent. So let's go through this file. So this script launches the Gemini VisionAgent as an A2A compatible server. When run, it sets up the agent and defines its metadata. So it will basically define the agent card and the agent skills, and it will listen for tasks like image-based queries from other agents or users. So you have the click and the logging import. So click is used to create command line interfaces easily. Logging is Python's built-in module to show logs. Then we import the A2A server class from the backend framework. This handles the HTTP server setup and routing. Then we import the data model that describes the agent to the outside world. So we basically import the agent card, the agent capabilities and agent skill. Now we import our custom Gemini VisionAgent implementation. Then we import the task manager, which connects this agent to our tasks. Then we have our logging setup. So we configure logging so that important events are printed to the console. Then we have the command line interface entry point. So we define the command line options using click. We provide an option to specify the host and the port. The default values are provided, so you don't need to actually specify it while running in this particular version. Now you have the main function. So this starts the Gemini Vision A2A agent server. So first we define what this agent can do. So we create an agent capabilities object. Here we say that streaming responses are not supported. Then we define the agent skill object. So this basically defines the skills offered by this agent, and it shows up in the directory on when discovered by other agents. So we provide the ID to the skill, which is vision_query. We provide a name, which is image query tool. Then we provide a description. So it answers questions about the content of an image, and input must be provided as a single string in the format, your question, and then double pipe, and then the image path or URL. This is an example. So what is shown in this picture with double pipes, and then we have given a URL for that image. We basically provide some searchable tags and some examples over here. Now we have the agent card. So this will create the agent card. That is the typical thing in A2A, which is used for discovery. And this is used by other agents or systems to understand or discover this particular agent and what all it can do. So we give it a name, which is Gemini VisionAgent, which we have seen previously in some of the print statements and on the console. So this is very similar to what we saw in the skill. So the agent answers questions about images using Gemini Vision, and this is the input format that we have seen before. And then we have seen the image paths before. So image path support for URLs provide direct image link such as this, and for local files provide an absolute or relative file path. And then we have an example input, like what is in this image, and then we have this URL, and the agent will load the image from the provided path or URL and answer the query accordingly. Then we have the public URL of this agent. So that's basically using the host and the port that we have specified above. We have a version of the agent which we can actually update when we update this particular agent. We have the default input modes and the default output modes. We have the capabilities and the skills from before over here. And this completes our agent card. Now the main script just starts the A2A server instance. So it will create the actual A2A server instance. It will pass in the host, port, agent card, and task manager. So we have the server over here, and then we start the server over here. So this basically then ties up everything together. So you have the agent. The agent is provided to the task manager. So the task manager is then provided to the server. So the server, task manager, and agent is what is tied all together over here. All right, so now let's look at the task manager. So let's click on this, and we have the task manager over here. So let's start from the beginning. So we have the VisionAgent task manager inside the agents directory, and this connects the Gemini VisionAgent to the A2A task handling system. So we have the regular imports for logging. Then we import the in-memory task manager from the server module. And this is what we have seen before. It's like a parent class that stores and tracks the tasks in RAM. And our VisionAgent task manager is going to extend this particular base class. Then we import the agent class that will handle the vision queries. So this is the actual agent. This will be defined in agent.py over here. Then we import the request and response types for sending and receiving tasks. We import the models that we need to use to structure the conversation task. Then we create a logger for this module, and it's good for printing out all the logging information. And finally, we have the agent task manager class. So this task manager class, we have seen that it connects the agent to A2A by receiving a task, extracting the query and file path, passing to the Gemini Vision agent for processing, and returning the structured result. So the agent task manager expects the query to be in a format which is query with a double pipe symbol and the file path. And then based on that, it can extract the query and the file path from that and pass it to the Gemini Vision agent. So we have the constructor, and we first call the parent constructor, and then we just assign the agent instance. So we can call its invoke method later. Then we have the get user query functions. This is going to extract the text query input from the request. So this is where we read what the user has typed. So we have the send task request, the object that comes in from the host agent, and then we return a string like describe this and then the path to image. So we return the complete string from here, and this is how we get the user query from the incoming request. Now we have the on send task. So this is the main handler that processes the incoming tasks, and the steps over here are that we first save the task in memory, then we extract the user's query from the request. We call the Gemini agent to process the image and get a response. And then we wrap the response in a message object. We mark the task as complete and add the message to its history. And then we return the updated task wrapped in a response object. So again, I'm quickly going to go through this because we have seen this in great detail in our previous lecture. So first we log that we are processing a new task, and this is just for visibility in the logs. We have the first step where we save the task in memory. And we have then the second step where we extract the actual text query from the request. So we get the query over here, and this will be something like, can you describe the image, with a double pipe and then the path to the image. Then we have a step 3, ask the agent to process the query and image. So we'll get the result text over here, and we'll call the invoke function for the particular agent. So we await this because invoke function is now async. So we need to wait for it to complete, and we get the result text. We look at this function when we look at the agent code. For now, we assume that this is able to take this particular query and then describe the image and send back a string with the result that, like, this is a photo of a dog, but it will be a much larger string than this, as we have seen in the demo. Then we format the result into a structured message object. So we get this as an agent message. We provide the role as agent, and then we provide a text part which has the result text. And now finally we mark the task as completed and append this message to history over here. And then we send this send task response back with the ID and the task. So this is how the task manager works, and we have seen pretty much all of it before. The only difference I think over here is that we are now awaiting the invoke function because this is now async due to some changes in the ADK. Alright, so now let's go to the agent code. So we can actually click on the invoke function, and this is going to open the agent.py file for us. So we are inside the Vision Agent's agent code. Let's go on the top. So this file defines the entire agent logic. So the Gemini Vision Agent class, and it uses Google's Gemini model. That's what we have been using since the beginning to define all our agents. And it answers questions about the images given in the file paths or URLs. So we have the general imports over here. So we'll import OS to provide functions to interact with the operating system. We import URL parse, which helps break down the URLs into components. Then we have path, which provides an object-oriented way to work with file paths. And then we have the Gemini LLM agent class from ADK. Then we have the runner from ADK, which is responsible for coordinating the agent, memory, session, and artifacts. Then we have the in-memory session service that manages the chat sessions in memory. We'll provide this when defining our agent below. Then we have the in-memory service. This basically stores the prior conversation context in memory. Then we have the in-memory artifact service, which stores files like images temporarily in the RAM. Then we have types, and this provides the structure for inputs and outputs. So like part, content, blob, etc. Then we have load.env, which is used to load the .env file that we had made. Finally, we have AIO HTTP, and this is an async library for making HTTP requests, and this is used to fetch remote images from the URL if that option is used. Alright, so over here we load the environment variables from the .env file. Then we have the Gemini Vision Agent. So we first define the supported content types. So over here we have the constructor. So we'll print that we are initializing this agent. Then we'll build the actual LLM agent using the build agent function. So we'll see how this builds the agent below, and we assign this to the self._agent. Finally, we give a user ID to associate session and memory over here, and then we create the runner object. So the runner object manages the agent and all the supporting services together. It ties it all together. So we have the app name, we have the agent itself, and then we have the artifact, session and memory services. Finally, we print that initialization is completed. Then we have the build agent function. So this returns the LLM agent that we are using above, and this is pretty simple. So we use the LLM agent from Google's ADK, and we provide a model. So we're using Gemini 2.0 Flash over here, and this is vision capable. So that's why we are using it. Also, we have the name. So we have Gemini VisionAgent is the name that we provide to it. We have a description. So it answers questions about images from file or URL, but we are depending upon the description in the agent card and skills for the host agent to understand what this agent does. Then we have instructions. So analyze the image and answer the user's question based on its content. And this is a system level prompt that the agent is provided. Finally, we print that the agent is built successfully and we return the agent. Alright, so now we have the load image part. So this is what is different from our previous implementations, because now we have an image part that we want to provide. So we provide the file path or URL to this function, and it returns a part object from the types library that we imported above. So it loads the image content from a local file or remote URL and returns a types.part object, which wraps the image data along with its MIME type. So it can either be image/JPEG or image/PNG depending upon the file extension that we have. The argument it takes is a file path or URL, and it returns the types.part, a Gemini compatible part containing the image as inline binary data. And we'll see how this happens below. So we first print that we are loading the image from the file path or URL that has been providing, and this is, we provide a tag over here which is image loader. Now we get the MIME type. So we determine the correct MIME type from the file extension. We have ext equal to path.lower.split. So we split it with a dot, and then we take the last part after the dot, like JPEG or JPG, etc. And if this extension is JPG or JPEG, you return image/JPEG as the MIME type. Otherwise, you return image/PNG if it's PNG. Else you don't know what it is, and we have not designed it for other extensions, so we'll just return a value error. In case there are some other file types that you want to cover over here, you can actually use those extensions over here and extend this. Alright, so then we have the next step. So this tells us if it's a URL starting with HTTP or HTTPS, and then we are going to print that detected a remote URL and attempting to fetch via HTTP. So we first get the MIME type using the function that we just saw above. Then we start an async HTTP session. So what we'll do is we'll use AIO HTTP for that and start a session over here. We send a GET request to that URL. So we use session.get and provide the URL over here. Remember that we have already checked that this is a case where the path provided is actually a URL. We get the response and we print that the HTTP status is response.status. If the status is 200, we read the image content into memory. So we say data equal to await response.read, and we say remote image has been loaded successfully, and we have this data over here. And now what we can do is we can wrap the image in a part with MIME type. So what we'll do is we'll use types.part. Initially we were just providing a text part, but over here we are going to provide inline data equal to, and that is basically a blob with data is provided as data and MIME type is provided as MIME type. So this basically wraps the image bytes inside a part with the respective MIME type. And we have some exception handling over here if we fail to load the image. Now if it's a local path, so this is the else condition to the if condition above over here. Again, we will need to load the image and provide and wrap it like what we did above. So what we'll do is we'll expand first to the full path over here. Then we'll print that, we have interpreted this as a local path, and we'll check if this particular path exists and if the file exists or not. If that is not true, we will raise a file not found error. Otherwise, we will get the MIME type like we did above. And now instead of getting the image data from the URL using the client and session, we just open the file and we do file.read and we get the data. And then we say that local image has been successfully loaded and the size is length of data bytes. And then we in a similar way wrap the image data into a Gemini part and we return that. So the load image part returns a types.part object, which is what Gemini expects with the image data inside it. And there is some header handling over here. All right, so now we have the invoke function, which is going to use all this. So what we do over here is that we take the query and the session ID, and we've seen this invoke function earlier as well. The only difference is that it is async because of some changes that were made into Google ADK, which made the session service async. So we need to await the creation of session inside the invoke function, because of which we need to make the invoke function async. You'll see that this change has been made to the previous versions as well. And now let's go down and check how this works. So we first print that this is a new invocation with session ID so and so, and the raw query is this. Then we validate the query format. So it must contain a double pipe, and remember that this agent expects the query in a certain format, which is question, double pipe, and then file path or URL. So if it's not there, then this is some basic validation to say that the input format is invalid. Then we split the input into question and image path. So we have the user question, which is just before the double pipes, and we have the image path, which is after the double pipe. Then we print what is the past question and what is the image path or URL. Now we are going to load the image part. So this will be a types.part object, what Gemini expects, as we saw above. And we'll just provide the image part, and this is what is going to do all the checking, whether it's a URL or a file, and based on the if-else condition that we saw above, it's going to give us a types.part object. We do some exception handling over here in case we fail to load the image. Now we get the session. So we used this we have used before. We try to reuse an existing session if it exists, and this is what's happened over here, that this function is now async. So we need to use an await over here. And if the session doesn't exist, we create a new one. Finally, we construct a content object with the image and the user query. So we have types.content. We provide the role user, which just says that the message is coming from the user and not the agent. And then we have parts. So we have the first part, which is the image part, and that is what we got above. And then we have the second part, which is a text part. So this is types.part from text, and the text in question over here is the user question. So we have this content. Now we can go ahead and invoke the agent actually. So we run the agent with this input and collect the responses. So for that we use self.runner.run async, and we use an async for. So this is going to get all the events that come in through runner.run async, and when we actually have the event object, assign it to the last event. So ultimately we'll get a last event from here, and we use and check that last event. So we handle the case where no response was returned by checking if there was no last event, or the last event does not have any content, or the content doesn't have any parts. And then we basically return this string over here that there was no response that was generated. But if the last event has content, we just take the last event, we get the content from that and get all the parts from that. And if that exists, we basically join all these text parts together using new lines. So we join all the response text parts and return as a single string. And this is the result that we return over here. And finally, we have some exception handling over here. So this completes the agent code for the Vision agent. And now you have the agent, the task manager, and the main.py file running together. This defines the entire Gemini Vision agent. Now the remaining part to this particular agent are these 4 images. So if you see, I have included these images in this particular folder, image samples AI generated, and you can use this for testing your code. We have checked with bus stop, and we have checked with the computer file over here. You can actually check with the butterfly and the rainbow file, or generate your own images if you want. So one more important change that I want to go through is for the Orchestrator agent. So let me go to this host Orchestrator agent and open orchestrator.py. So what I've updated over here is the list agents function. So earlier the list agent functions only provided you with the available agent names, but that was not sufficient for the orchestrator to understand what are the capabilities of that particular agent. So what I've done is that we have basically provided now a summary for each agent. So there's a list of summaries that this list agent functions return. And if you remember from our previous lecture, the orchestrator agent uses the list agent function to discover the other available agents and what are their capabilities. Till the agents were simple tell time and greeting agents, the names were sufficient, but now, for example, for the vision agent, we have more details, like what the vision agent does. It describes the image and it needs a specific input format. All that cannot be fit into the name. So now this list agent returns a detailed list of registered agents with their skills, and the format that it uses is like this. So it has a list with agent name, colon, and agent description, and then skill 1, skill description, skill 2, skill description, and so on for each agent. So this will finally be a list of strings, and each string will be dedicated to one agent, and the list will cover then the entire set of agents that we discover. This is what it will return in the end. So we define an empty list to begin with. Then we check for each card in agent connector keys. So agent connector keys are basically the agent names, and the agent connectors are what we use to connect to different agents. So we'll get all the agent names over here. Then we get the agent card for that particular agent using self.agent cards. So if you go to agent underscore cards over here, you see that we are getting the list of agent cards for the orchestrator agent in the constructor when we actually define the agent. So we're actually passing in the agent cards and assigning it to the agent underscore cards property over here. All right, so for each agent, we get the agent card, and we then define parts equal to agent card.name and agent card.description. So this is the first part of the string, which we have the name and the description of the agent. Then we go through each of the skill, we get the skill summary, and we append it to the different parts. And finally, we join all these parts. So the agent name, description, and the skill names and descriptions. And we join this by separating it with a pipe symbol with 2 spaces on each side. So we have this single string for the agent, and then we append this to the summaries list that we have above over here. Then we go to the next agent and we do the same, and the summaries list gets the second string for the second agent, and finally we return the summaries over here. So this is the function update that I have made to the list agents functions, so that when the orchestrator agent lists all the agents, it gets more detailed information about what the agent does and what are the different skills. So this completes all the explanation for the vision agent, how it works, how to set it up, and how does the code work. And try it out with different images over here, and let me know in the comments if you face any issues or how you find this. Try it out with your own images and see if it works on different images. Ultimately, it's the Gemini model that is actually providing the results to you, and it works very, very well as far as my experience goes. Thanks for watching, and I'll see you in the next video.